All right, so what we're going to talk about today is, well, this is the very beginning to talking about quadratics. Now, whenever you have a quadratic, it's a parabola, and let's say this is what your parabola looks like. This middle point right here is called your vertex. And this point is how you technically move a quadratic. So let's say you have a quadratic in this location, and I want to move the whole thing over here. I move it a certain unit right and a certain unit down. Or I move it a certain unit left and down, or left and up, or whatever you want to do. This, think of it like taking this piece and then moving it, and the whole U moves with it. Now, quadratics are very, very in-depth, and we're going to be spending about a month covering quadratics. But I'm going to show you how to move this little point right here. Because if you move this little point, let's say right here, to this point, technically, the shape stays the same, except this point, let's just call this vertex. Let's say it's -3, 1. -3, 1. That's the point, because every point on the xy coordinate plane has an x and a y. And let's say I move it all the way down here. Let's say this new point right here is, let's say, 8 on the x and -2 on the y. So technically, I slid it. If it was at -3 and I moved it -3 on the x, I moved it all the way to 8 units on the x, I slid it 11 to the left. And if it was at 1, now it's all the way at -2, because think of it moving 11 units, this moving 11 units to the right. Boom, right here. And then I move it 3 units down, I'm at -2. See how I'm at 1 and then I get to -2. So technically, this moved from here to here, 11 units to the right and 3 units down. Whenever you move a graph, or it's called a slide, what this is called is a translation. A translation is a slide. So we would say that this translated 11 units to the right and 3 units down. A slide is the same thing as a translation. All right. Now what I'm going to do is I'm going to show you how you actually move a graph. Now I'm going to use kind of like a chart. We're going to call this chart the translation chart. Okay, now with this chart, I'm going to take a basic equation of y equals x squared. This graph looks like this. If you were to plug y equals x squared in your calculator, it would look exactly like this, because the vertex is 0, 0. This is in the origin. Now what I'm going to do, I'm going to move this 1 unit left, 1 unit right, 1 unit up, and 1 unit down. And I'm going to show you how I do that with this graph. So let's take y equals x squared. And what I'm going to do, I want to move it 1 unit up. If I want to move it 1 unit up, what I'm going to do is I am going to rewrite this as y equals x squared plus 1. If I add a number next to the graph, it moves it 1 unit up. Now, let's take this same exact graph, and I'm going to move this 1 unit down. Or if I want to move it down, I take my original graph. I should have done this in 2 different colors. So I'm going to redraw this. Y equals x squared. I'm going to leave the green for plus 1. So if I were to take my original graph, y equals x squared, And if I want to move it down, I'm going to subtract 1. What that looks like is, sorry, it's not a straight line, but whatever. So my original graph was y equals x squared. If I add 1, it moves this 1 unit up. If you want to move it up, you put a positive 1, which is going to look like this. Now, if I put a negative next to that, it's going to take this and move it down 1. Okay, let's take this original graph, y equals x squared, and now I want to move it to the left. The way you move it to the left is you make this a parenthesis. So if we were to go y equals, and I'm going to put a parenthesis x, now I'm going to move it 1 unit to the left. If you're moving it 1 unit to the left, you put a positive 1 inside the parenthesis. It's the opposite way. And you square it. Whenever you want to move it left and to the right, you put it inside and then you put it squared. So the way this is going to look is, if I have x plus 1 squared, all this is a translation of 1 unit to the, it's not positive on the x, it's negative, it's opposite. So it's going to be, let's say right here. And the same thing, if I want to move it to the right, you do y equals x. It's the opposite. So if you're moving it to the positive on the x, it's a negative 1. I should have put it in a different color, but whatever. Negative 1 squared. So this is going to be right here. If it's a negative, it's actually moving towards the positive. And that's how you shift a graph left, right, up, and down. Now let's say this. Let's take some examples. I want you to, let's try and graph y equals x minus 3 squared. Well, normally I'm going to draw something called a parent graph. A parent graph is a graph that shows you what the graph would look like before you messed with any part of it. So if this is the parent graph, y equals x squared, which is right here. Now if I put a negative inside parentheses, let's look what happens. When I put a negative inside a parenthesis, look, here's my negative. It actually moves to the opposite way, towards the positive. So this is going to go 1, 2, 3. 1, 2, 3. Boom. And here is my new graph. So if you were to graph this on a graphing calculator, this is exactly what it would look like. Okay, next thing. Let's say I'm going to graph, I'm going to combine a couple things. Y equals x plus 1 squared minus 2. What does this parent graph look like? It looks like this. Before you mess with it, your vertex is in the origin right here. Now, I am moving it 1 unit to the opposite. What happens when you put a positive in? It goes to the left. It's moving 1 unit to the left and 2 units down. So this is going 1 and then 2 right here. There's my new graph. Let's see if you guys can graph this. Let's try y equals, let's say, x plus 4 squared plus 1. Pause the video and see if you can graph that real quick. Okay, if you pause the video, you should have gotten a graph that looks like this. This moves 4 units to the left, 1, 2, 3, 4, and 1 unit up, right here. So here it is, right here. Now, if you notice something, the number inside is always your x coordinate for the vertex, but it's the opposite. The number on the outside is always your y coordinate, and it's normal. Meaning, what's my vertex here? It's negative 4, 1. But look at this. This is a positive 4, but it's the opposite, negative 4, 1. What's my vertex here? Negative 1, negative 2. Look at here. Negative 1, because it's the opposite, negative 2. What's my vertex here? Well, this is the same thing as saying negative 3 squared plus 0. So it would move to the right 3 and then up or down nothing. So my vertex would be a positive 3 because it moved to the opposite, positive 3, 0. So with this, you don't really need this chart at all because technically you can just graph. You can just straight up graph anything. Let's say graph this, y equals negative x plus 4 squared minus 1/2. Okay, now this is going to be a little different because let me graph the original parent graph because this is what's messing some people up right now is this negative. And I'll explain this in a second. If I were to change this parent graph to look like this, it would be y equals x plus nothing squared plus nothing, right? Because x plus nothing is just x squared, plus nothing is just x squared. So technically, these two are the exact same thing. The reason why I'm doing it like this is because now my x and my y is my origin. This number is an invisible, there's an invisible 1 here, which is the same number right here. So the way that you create your graph is this. The way that you have a U, this is how this is called your initial shape. This is a positive 1. So what I'm going to do is from this vertex, I'm going to go up 1, over 1 on both sides initially, and that's it. I'm not going to continue this forever. I'm just going to go up 1, over 1, up 1, over 1, up 1, over 1, and then graph. Boom. Oops, I'm sorry. It's not a V, it's a U. So it's going to look like this. Get rid of that. And that's what it's going to look like. Okay, now see this negative? We're going to keep this concept in mind because I'm going to graph this now. First off, my vertex is negative 4, negative 1/2. So that means I'm going to go 1, 2, 3, 4, negative 4, and negative 1/2, so down halfway. Now my shape is a negative. There's actually an invisible 1 there, negative 1. So instead of going up 1, over 1, up 1, over 1 like I did normally, I would go down 1, over 1, down 1, over 1 because it's a negative. And then I draw my U. This is called your initial shape. It's not, you don't go down 1, over 1 forever. You just go down 1, over 1, down 1, over 1 initially, and you leave it. We're going to graph these a lot more precise later on. But for now, just think of it like this. Okay, the very last thing I'm going to do is this. Let's try and have you graph this. Y equals, let's say 2 times x plus 3 squared minus 5. Pause the video and see if you can graph this. All right, if you paused it, let's see how you did. So I'm going to find my vertex first, which is its opposite, negative 3, negative 5. Because it moves the opposite 3 units to the left, down 5. 1, 2, 3, 4, 5. Right here. Now, it's going to be facing upward because my shape is a positive. And I'm going to go 2 over 1. So up 2 over 1. Up 2 over 1 on the other side. And that's it. That's what I'm doing. Now, this is that graph right there. That's it. This is called vertex form or graphing form. The reason why it's called vertex form or graphing form because you know your vertex and your shape. The other type of graph that I'm going to do is, let's change this to an absolute value. Let's say 2 times, I'm going to keep this exact same graph, absolute value of x plus 3 minus 5. I'm going to show you the difference with these two graphs. This is still your vertex. Absolute values are like these, but they're v's. I'll show you. So if I were to graph this, my vertex is still -3, -5. -3, -5. Okay. Now how I'm going to do, sorry, I just had to pull away for a second. Now, this +2, remember how in this I just went up 2 over 1, up 2 over 1 initially? This makes it linear. Absolute value is linear, so you go up 1, 2 over 1, and you continue this infinitely. Then you go up 2 over 1, and you continue this, so it's technically 2 linear equations giving you a line. Look at the difference between these two. This is called a quadratic because it's a U. Absolute values are V's. That's the difference between the two.